Okay, I'd like to do another problem. Oh boy, excuse me. Here we go. I want to look at 32. The last video just got cut off. Sorry about that. 32 is right there. Again, if I throw in theta equals 0, I will notice I'm getting 0 over 0. I can't use L'Hopital. I wish. That would be such an easy problem. So here what we're doing, we're pretty much trying to figure out what this is. And we know what that is. We worked on that a few times. It's right here. It's in the table provided. I'm sorry. In the previous. It's in the table provided. The sign is right there. So that is, sine of theta is theta minus theta cubed over 3 factorial plus theta to the 5th over 5 factorial. Oh boy, I'll get it right. So that's going to be theta minus theta cubed over 3 factorial plus theta to the 5th over 5 factorial minus theta to the 7 over 7 factorial plus. So that's what this sign will equal. And that would be the limit as theta approaches 0 of theta to the 5th minus theta. I should have changed colors, but I messed up. Sorry about that. That's okay. Let's say this was, oh boy. Let's say that was green. So that would be theta minus theta cubed over 3 factorial plus theta to the 5th over 5 factorial minus theta to the 7 over 7 factorial. And what do you notice? Because 3 factorial is 3 times 2, which is 6. So I am left with this infinite series. I am left with theta to the 5th over 5 factorial minus theta to the 7 over 7 factorial plus theta to the 9 over 9 factorial. And the list goes on over theta to the 5th. If I split those, that would be theta to the 5th over 5 factorial minus theta to the 7 over 7 factorial plus theta to the 9 over 9 factorial. So if I break this up into pieces, well, guess what? That will simply be 1 over 5 factorial minus theta squared over 7 factorial plus theta to the 4th over 9 factorial. As theta approaches 0, those would be 0 and you'll be left with 1 over 5 factorial. And that would be it. That would be what the limit equals. Now, I want to do one more and elaborate on a couple of things. I was going to leave lecture on it, but the lectures are coming out a bit longer than I want it. I want to pick one of those. Now, the table is in front of you on the exam, so you're given that table. You just want to really play with it. If you ever do this work for a long time, you'll be able to see those really quick. So if I pick one of those, any one of them, let's say if I picked, let me see which one. Let's go with, I'm going to go with this one first. It looks messy. Looks could be deceiving. So use the table that's provided on the test. Well, what you're trying to do, you're trying to figure out what is changing. That is 2 to the 1 minus 1 over 3. Isn't that 2/3 cubed? Isn't that 1 over 5? Time out. Yeah. 2/3 to the 5th minus, isn't that 1 over 7? 2/3 to the 7th, and the list goes on. So actually, if I'm trying to get a pattern, wouldn't that be there we go. So wouldn't you say this is actually a power of 1, 3, 5, 7, right? And I'm trying to look at this table and figure out which of those matches. I'm looking at raised to the 1, 3, 5, 7. It's definitely not those. Not this. There, right there. 1, oh, but that's factorial. Nope, we don't want factorial. So, what? Oh, right there. 1, 3, 5, right? So if I glance at this, if I take the tangent and I glance at the other problem now, I'm looking at a quantity raised to the 1, a quantity raised to the third power over 3, a quantity raised to the fifth over 5, right? So I could rewrite that one more time. 2 over 3 to the 1 over 1 minus 2 over 3 if it makes you see it better. 2 over 3 to the fifth over 5 minus 2 over 3 to the 7 over 7. Now I am going to copy that in here, or I'm just going to point it out. Let's see if it makes sense. Right there. 1, 3, yeah, perfect. And what did we get? It is alternating 2. We say that's the tangent inverse of 2/3. There it is. I want to pick one more. Let me look at these problems. And I don't know which one to look for. Let's see. I don't know. Again, they're all the same. Let me see. Maybe. Okay, maybe 42. If I look at 42, I notice none of these start with a third power, but I notice that 1 over 4 to the third power is common in all of those, isn't it? Can't I say this is 1 plus 1 over 4 to the 1 plus 1 over 4 squared plus 1 over 4 cubed plus, actually I don't need the power series for this, I know what that is. I could say, let's say you didn't see it, I see it, this is geometric. But let's say you didn't see it. Do you see where that is? 1 plus x squared plus x cubed. Isn't that all 1 over 1 minus x? So 1 plus 1, 2, 3. Isn't that 1 over 1 minus? And what's x? Isn't that 1/4? I don't need that much space. Not a fun problem. Well, somewhat, I guess. It depends who you ask. That is 1 over 4 to the third times, and what is that? Isn't that 4 over 4 minus 1? So that's 1 over 4 cubed times 4 thirds. That is 1 over 4 squared times 1/3. 16, 1 over 48. Alright, not a whole bunch of time left. I did want to talk about remainder, but that takes time. I do want to point out a couple of things. If I have the series n equals 0 to infinity of x to the n, that is 1 plus x squared plus x cubed plus x to the fourth, and the list goes on. Assume this is over n factorial. If this is f of x, if I take a derivative of that, so if I take a derivative of this, wouldn't the derivative of that be 0 plus 1 over 1 factorial plus 2x over 2 factorial plus 3x squared over 3 factorial plus 4x cubed over 4 factorial? Wouldn't that be 1 plus x over 1 plus x squared over 2 right? Hey, that's matching. That's still factorial. That's still 2 factorial. Well, no worries. If this is what I have and I want to take a derivative, guess what? All what you do, you bring the power down, subtract 1 from the power. But, do you see that by taking a derivative, I lost a term? I will have to boost that index 1 up. And, if I want to adjust this, that is, if I want to make that x to the n, I could do that. I am going to boost this one up, boost this one up, boost this one up, and to compensate for boosting that up, I have to boost this one down. You could fix that if you wish. You really don't have to, but, and wouldn't you say this is n plus 1 times n factorial? Wouldn't that be the series n equals 0 to infinity of x to the n over n factorial? Right? So the key is that if I want to take a derivative, I could treat this like a power function, bring the power down, subtract 1 from the power. And if I wanted to integrate the series n equals 0 to infinity of x to the n over n factorial with respect to x, guess what? C plus the series n equals 0 to infinity. N is a constant as far as the x is concerned. All what you do, you add 1 to the power and you divide by that, just like you did with polynomials. Something that we didn't get a chance to play with a lot, and there aren't that many problems to begin with, but there it is. I'm gonna fill in the homework, and there's your homework, and that would be 1010. 1010, page 655. You're going to do numbers 1 through 13 odd, 29 through 33 odd, 41 through 45.